So for our MCHE 3920 project, we decided to create an electric hoist using mostly 3D printed parts. Our group consists of Austin Hupfaker, Jason Moran, John Paul Jones, and Will Strickland. Obviously, a hoist made of 3D parts isn't going to lift heavy weight like these high-end hoists, so our goal was to lift 20 pounds. We intentionally chose a low torque DC motor that was incapable of lifting 20 pounds. We did this so that we could try to use the gears and pulleys to create a mechanical advantage. To create the 3D printed parts, we used the 3D printer in the Driftmeyer fabrication lab. Jason designed this gearbox on Fusion 360, so it's a 10:1 gear ratio with mounted ball bearings, and our original plan was to 3D print the bearing mounts, the shafts, and the gears, and then we were going to purchase non-printable items like the ball bearings on Amazon. The gearbox contains most of our 3D printed parts, and with the Driftmeyer printers not being super high-end models, we did run into some tolerance problems right off the bat, even though it was accounted for in Fusion 360 in the CAD drawings. We had tolerance problems with the base mounts for the ball bearings, and also with the gear holes being too small to slide onto the shaft. So we had to work around these problems by trying to sand down the inside of the gear hole or printing new ones. And another problem we encountered was with warping of the gears and shafts. The circular shaft was deformed due to the printer bed not being calibrated. So the gears came out oval shaped, and because the XY plane wasn't calibrated correctly. But once we got these issues resolved, the prints came out pretty smoothly with no warping or deformation. But even after dealing with tolerances and deformation, we discovered that drilling into the 3D printed ball bearing mounts would not work. Luckily, we were able to glue them onto the frame, and after all, we're not lifting too much weight with this hoist. Our goal was only 20 pounds, and finally, after all the troubleshooting, we began to make progress on the device, and this clip right here shows the first 10:1 gear reduction. The motor is rated at 20,000 RPM, which means the gear is turning at 2,000 RPM. And this first bit of success restored hope in our design, and only a few hours later our project was a success. And here's a clip of a demonstration of the electric hoist in action. So as you can see from the video, the electric hoist is fully functional, and according to the calculations and data sheet, it should have been able to lift at least 150 pounds, but unfortunately we never got to test it. Probably the most challenging issue we encountered was the tolerance issue. We only got the right fit 2 out of 7 times without having to sand it down, but we overcame this problem and we are happy with our final product.